Hey guys, Miss Parrish here. I'm going to bring you our lesson today on area of polygons, or in other words, complex shapes. Okay. What we've done up until now is we've found the area of just simple shapes: squares, rectangles, triangles, trapezoids, rhombus, things like that. So, what this lesson is going to do is it's going to have what they call a complex shape, which is a shape made of two of those shapes put together. Okay. So, you want to definitely have some paper handy because you're going to want to copy the examples down and make sure you're following the instructions on this. It can be a little more complicated because you're having to do two area formulas for each problem. But if you'll copy the notes down and work them step by step like we've been doing, hopefully this will not be too difficult for you. Okay, so get a piece of paper, and you should have or your if you're working from home, you should, or if you were a student that's been at school, you should have your orange formula sheet. If you're been working from home, you should have those formulas written down on one of those sheets or on a piece of paper somewhere as well. All right, we're still in the same standard we've been in, 6G1, which talks about finding the area of all these shapes. Again, you can use your orange formula sheet if you've got that from being at school, if you're at home and have that. Um, if you were not at school to get the orange sheet, you should, again, like I said, have these formulas copied down somewhere. But just in case, we're going to review them very quickly. If you remember, square and rectangle have the same formula, which is area equals length times width. Parallelogram has a pretty simple formula, which is area equals base times height. The rhombus had two that you could choose from. You could do 1/2 times diagonal 1 times diagonal 2, or you could do area equals diagonal 1 times diagonal 2 divided by 2. So you could use either formula on that. Um, the trapezoid was the one that was the longest formula, and it was area equals 1/2 times the height times the sum of base 1 and base 2. And then triangle, kind of like the rhombus, we had two that you could choose from. You've got 1/2 times the base times the height, or you could do area equals base times the height divided by 2. Okay, most people like that when you just multiply the two numbers and take half of the answer. If you need to pause this and write any of those down, please feel free to do so. All right, this is very important that you write this in your notes, okay? You definitely want to write the steps to solve these problems, all right? Because like I said, these are a little more complicated. So if you have, apologize, if you have the steps, you can look back to make sure you're doing the correct things. So 3 simple steps. Um, Number one, you want to divide your complex shape into two shapes. Okay, like I said, a complex shape is a shape that is made up of at least two more polygons. All the ones we're doing today are only going to be two shapes put together. So divide that into two shapes. And then once you know what two shapes you're dealing with, you find the area of each of those shapes. So if you've got a square and a triangle, when you split it up, you find the area of the triangle, then find the area of the square. And then finally, after you've found the area of both shapes, you just add those answers together. Okay. So again, if you need to pause this, feel free to do so to copy those steps down. It's a little easier once we actually start working them. All right. So let's look at this first shape. Now, if you can, you need to try to draw this shape on your notes. Um, this one's pretty easy to see what you've got going on. I would draw a rectangle first, and then you can connect I would go ahead and just draw the rectangle, and then you can go back and add the triangle to the top. Just draw it to the best of your ability. Don't, stress out making it, thinking it has to be exactly perfect. So draw that. Make sure you are labeling the measurements as you see here. Okay. So once you get that drawn and labeled, You'll notice this one's kind of helping you out. You've got this little dotted line right here. Sometimes you don't have that, but in this case, we've got this little dotted line. So that one's kind of dividing this one for you. Okay. So on this, you can easily see that the two shapes you're dealing with are the rectangle, which I kind of gave away when I said that. But you have a rectangle and you have a triangle. All right. So I'm just going to go ahead and um, draw my line like that to kind of separate them. Sorry. If you could see the computer I'm using at home, my hand is writing kind of straight up and it's a little difficult. So we have a rectangle and a triangle. So the first thing we want to do is we want to identify our two shapes. So I'm going to go to the side and I'm going to abbreviate. I have a rectangle and I have a triangle. Okay, so I've identified my two shapes. Now let's write the formulas for each of those. You should hopefully have them memorized, but if not, look at your formula sheet. So formula for rectangle we know is length times width. And formula for triangle, again, you can do the 1/2 base times height, or you can do base times height divided by 2. Either way will get you there, okay? I will probably just do base times height divided by 2 just to make it a little easier, but either way will get you there. All right, so the first thing we have to do is we have to find the dimensions of this rectangle. Now, that can be a little tricky because we've got numbers kind of everywhere. Okay, so one thing I recommend, and you can't see me doing this from home, but if I was in class or if I had this on a worksheet, I would take my hand. I'm going to start with the rectangle. So I would take my hand or a piece of paper or something, and I would cover, like I said, you can't see me doing it, but I would cover the triangle with something. So with my hand or a piece of paper, that way you can just see the rectangle. And sometimes that makes it easier to figure out which numbers you need to use. So if you drew that, kind of put your hand over the triangle part and you're just looking at your rectangle. And when you look at the rectangle, you can see that the length of the rectangle is 16 and the width is 7. Okay, so I'm going to plug my numbers in for this. Area equals 16 times 7. And then I'm going to multiply those two to get my answer. Okay, so 16 times 7. And I get 112. Okay, now this is centimeters, so centimeters squared. So the first thing I do is I find the area of the first shape. So I found the area of rectangle, pretty easy. Now I've got to find the area of my triangle. Now this one's a little trickier. Again, you can cover up the rectangle, but we might need to see some of those numbers. Okay, now this is why it gets a little tricky. Here's my triangle. Okay, I need to know the base, which runs right here, and I need to know the height, which runs right here. So that's where it gets a little tricky because I don't have numbers exactly placed there. So this 13 is representing the length from the top of that triangle to the bottom of that rectangle. So the 13 is the entire thing. I don't need that. I just need this little part. Okay. So I need to figure out, in order to figure out what this part is, I can look at this, and if I look across from it, that is 7 centimeters. So that would mean this side would be 7 centimeters. If this is 7, this part right here is the same. So that would be 7. So you think about it this way. The whole thing is 13 centimeters. This much of it is 7. So if I have 13 and I take the 7 away, 13 minus 7 is 6. So that means that the base of my triangle is 6 centimeters. 6 and 7 make 13. 13 is the total. So the base of my triangle is 6. Now I need to find the height. Okay, remember you never use the slanted side. I need to find the height. Well, again, I need just this part. Well, this much is 8 over from here to here. This is 8. So, but I got to figure out what this is. Well, this entire length of the rectangle is the same as this length. Those are both 16. Okay, so if the whole thing's 16 and this much of it is 8, what's 16 minus 8? It is 8. So now I know, see, 8 plus 8 equals 16. That's the length of the whole thing. So my measurements for my triangle are going to be base times height. So 6 times 8 divided by 2. 6 times 8 is 48, and 48 divided by 2 is 24 centimeters squared. Now, again, remember, you can use a calculator as long as you're writing all this down. You can use a calculator on these area problems as long as you're showing your lines of work. Okay. Now, I found the area of the rectangle and the area of the triangle, but we want the total area of the entire polygon. So this is where, once I've done that, here comes the easy part. I take 112 plus 24, add that up, 112 plus 24, and I get 136 centimeters squared. So the area of the entire polygon is 136 centimeters squared. Okay, the main part that's kind of tricky is finding those missing measurements. That's where you want to look. You have to take the numbers you know, and usually you have to subtract something from those. Okay, again, this is a little tricky. Hopefully, it'll get easier as we do it. So if you need to pause this and finish writing any of that down, please do so. All right, let's look at the next shape. If you want to take a second and draw this one and label all of the measurements. If you need to pause to do that. All right, looking at this one, you got a couple of different options here. And sometimes on these shapes you do have. This one does not have it divided for anywhere for me like the last one did. So you got two choices on this one. I can either go from this corner across here, I can divide it there, and I would have a rectangle and a smaller rectangle. You could also, if you prefer, that's kind of the cool thing, sometimes you got choices on these, you could also divide it right there. Okay, either way, you'll get the same answer. Okay, so whichever way you want to divide it, you can divide it this way, or like I said the first time, you can divide it the other way. Okay, I'll just leave it like this since this is the last way I divided it. So looking at this again, it appears that I've got two rectangles. Okay, now they're not going to be the same size, but I can tell by looking at them. So I can't just say, oh, I'll do one rectangle formula and multiply it by 2. You can't do that. They're not the same size. We've got to do two separate formulas. Okay, so we'll just call this rectangle 1 and rectangle 2. We'll call this one 1 and this one 2. Okay. Now looking at this one, I can see the length is 60 and the width is 20. Again, if you want to put your hand or a piece of paper over that rectangle 2 to block it out for a minute so you can see, you can do that. But this one's going to be 60 by 20. So 60 times 20. Okay. 60 times 20 on your calculator is 1,200. What are we using? Feet squared. And some people like to write that in. Okay. Put this is number 1 and this is number 2 so we don't confuse those numbers. You don't have to number them. I was just doing that so you could see. But my area for the rectangle 1 is 1,200 feet squared. You can write it in. Some teachers may want you to, or not. That's up to your teacher. So now we've got our second rectangle. Now I do have the numbers 30 and 60, but I have to be very careful. Okay, 30 does represent this side. Okay, but now 60 is covering the entire thing here. I don't need the entire thing. I just need it from here to here. Okay, so I got to figure out what would be the measurement, and sometimes it's good to trace around your shape. Okay, the entire thing is 60. I don't need that. I need this much. Well, if I look from here to here, opposite ends are the same measurement right there. This is 20. So if this length is 20, 60 minus 20 would be 40. So that means this length is 40. 20 and 40 equals 60. So the two numbers that I'm going to multiply together for this one will be 40 and 30. Okay. Again, when you've got an entire length, that's your total. So these two numbers should add up to be that when you're finding a missing measurement. All right, so now I'm going to multiply 40 times 30. Believe it or not, I get 1,200 again. Who knew that would work out? 1,200 feet again. So now I'm going to add those two together. Okay, so the area is going to be 1,200 plus 1,200, which equals, if you can almost do that one in your head, 2,400 square feet. Okay, so the area is 2,400 square feet. You could have even written that if you wanted to. You could even do that if you prefer. Make it a little neater like this. 2,400 square feet. And that's the area of the entire polygon. That one's a little easier, two rectangles. Okay, if you need to pause this, please do so. All right, now we're going to kick it up a little bit. All right, we're going to challenge a little bit. This is a very unusual looking shape. Again, you want to see where can I divide it that I can see two distinct shapes, two, shapes that I know for sure that we have dealt with out of all of those we've worked with so far. So you could, if you drew a line here, well, you would have a rectangle up here, but what in the world is that? Okay. And you don't want to divide it into three shapes. You could, but that's just extra work. So we don't want to have to do that if we don't need to. So we don't want to divide that one here. Okay. If you've not already drawn it, I should have mentioned to draw that first. Hopefully you remembered to do that. Take a second and draw that one. And when you're drawing it, I know sometimes they're kind of hard to draw. If you'll notice, I'm going to divide this one right here. Sorry, that's not the best line. And now I can see that I have a square. So if you want, and then this shape looks a little unusual. Some people have trouble each year figuring out what this is. Think of the shapes that we've dealt with so far. Okay. Every quadrilateral that we've dealt with has two sets of parallel sides except for one. Which one is that? Which one only has one set of parallel sides? It's a trapezoid. Okay, clearly this is not a triangle. It's not a square. It's not a rectangle. It's not a parallelogram or a rhombus. It is a trapezoid. We have one set of parallel sides. Okay, so now we know we're dealing with a square and a trapezoid. All right, save time. I'm going to abbreviate. What's our formulas? Square is easy, length times width. Trapezoid's that long one. 1/2 times the height times the sum of base 1 and base 2. Okay. So remember a square, the reason I know this is a square and not a rectangle, not that it really matters, they have the same formula, but you do want to be able to identify that this is a square. Remember, a square has the same measurement on every side. So if that's 18, this is 18, they have the same measurement. So I know that's a square. So again, you can cover the trapezoid with your hand and you can easily see that the measurement of the square is 18 times 18. Okay, write that down. Make sure you're doing all of your lines of work. 18 times 18 is 324. And what are we dealing with? Inches squared. So my square is 324 inches squared. Now we've got a little harder formula. Again, we got to pull our numbers out of here a little bit. Okay, I'm going to trace this trapezoid. And if you have, I didn't even think to mention, sometimes in class, we let you use colored pencils or highlighters. And sometimes it helps if you will trace each shape with a different color. It makes it a little easier to see those. If you want to pause this and go grab some colored pencils or crayons or highlighters, that might help you. Sorry, I didn't remember to mention that sooner. But now I can look at my trapezoid. Okay, now remember, on a trapezoid, the height or I'm sorry, the bases are my parallel sides. Okay, my bases are my parallel sides. So if I look at this trapezoid, here is a parallel side, remember the parallel sides are the two sides that run the same distance apart and never meet. Think of train tracks, think of sides of a ladder, something like that. So this part and this part, these two sections are my bases. Okay. I can see that this one's 18. I'm even going to label it with the letter B for base. Okay, now I've got to figure out the measurement of this one. You don't want to count 18. Yes, that line goes all the way up, but that's not all part of my trapezoid. The part of my trapezoid is only right here. Okay, so the whole thing is 18, like over here, but I just need this much. Okay, so I can see this 9 is not the slanted side. The 9 is pointing to this part right here. So I need to know 9 plus what gives me 18? Well, 9 plus 9. Okay, so my other base is 9 inches. So I know my bases. Now I've got to figure out my height. Now remember, your height, it's going to be a little harder to find on this, is the line that connects the two bases and it forms the right angle. Look for that little box right there. Okay, remember, you never want the slanted side. So this has to be my height. It's a little harder to see because it's not that dotted line inside, but it's running from base to base. And there's my little right angle. I said it kind of looks like an H with the line in the box. Now, 36 represents this entire thing. We don't need that much. We just need this much. So how do I know how much this is? Well, this is 18. This line up here is 18. So that means this must be 18. Okay, so 18 plus what is 36? Well, if I subtract 18 from 36, if you're not sure, just subtract it on your calculator, and you see that it's also 18. So my height, sometimes on these you want to label. So my height is 18. Okay, so I'm going to do 1/2 times the height, which is 18, times the sum of my two bases, which were 9 and 18. And then you're just going to work your trapezoid formula. Remember when we did the trapezoid formula, we did the parentheses first. Okay, so when you add your 9 and 18, you get 27. Then the next line, you're just going to work it in order. Half of 18. I told my kids, if you can do it in your head, half of 18 is 9. If you can't, you would say 18 divided by 2. Anytime you take half of something, you just divide it by 2. So now I'm down to 9 times 27. Type that into your calculator. And you get 243 inches squared. So remember, our last step is to add our two totals together. So the area is going to be 324 plus 243 plus 324. And I got 567 inches squared. Okay. These are a little work. They take a little persistence. Okay. You can't give up on them. Okay. Do the shape you feel comfortable with first, and then move to the next one. Okay, so there's a square and a trapezoid. That's a real good one to look at. Please make sure you're copying all of these shapes. Make sure you're copying all of the work down because that will help guide you when you have to do these on your own. Okay, I'm trying to think. All right, let's look at this next one. Okay. Draw that one, label. That one should be fairly easy to draw. Let's see, let's go to this one for a second. I'm sorry. That one was too much like the last one we did. We'll do a real world problem. All right. We want to find the area of the garden. Teresa wants to buy mulch for her garden. One bag of mulch covers 12 square feet. How many bags will she need? So this is almost like one of those multi-step problems we did on Monday. Okay. So draw that garden. That should be fairly easy to draw. Okay. Label your shapes. I apologize about that last one. We kind of did one like that earlier, so I wanted to get to one of these word problems so the video is not too long. Okay, get that one drawn. Now, um, you can divide this one a couple places. You could divide it right here. It looks like this one's kind of got a little dividing line already, so we'll just go with this. Okay. Again, if you want to trace the shapes separately, trace those, you can trace those out. Sometimes that helps. Okay. Different colors. Mine's not different colors, so I may not trace them both. It won't help much. But if you look, we do have two rectangles. Okay. Two rectangles. Now, what is my formula for area of a rectangle? Easy peasy. Length times width. Ooh, I'm getting messy here late at night. I apologize. Okay. Later it gets, the worse my handwriting gets during the day. Sorry about that, guys. All right, so we'll call this one rectangle 1, and this can be rectangle 2. You don't have to draw all those flowers and all that stuff in it. So for rectangle 1, again, if you want to take your hand and cover rectangle 2 so you can focus on the numbers you need for rectangle 1, I can see that my length is 15 and my width is 9. So for rectangle 1, I have 15 times 9. Okay. And if I multiply 15 times 9 on my trusty calculator, I get 135. We're dealing with feet, so feet squared. So the area of rectangle 1, 15 times 9 is 135. So now I want to do rectangle 2. Okay, again, you may want to either trace the shape with a colored pencil, or you can just take your hand and cover rectangle 1 so you can focus on the measurements of rectangle 2. Now here's rectangle 2. This is part of rectangle 2, so my length is actually going to be 24 feet, so that works out easily. My width is not going to be as easy to find. I don't have a number here, and the number here tells me it goes all the way from the top to the bottom. I don't need all of that. This rectangle only has a width of this much. See, it has to match this side. Okay, so if the whole thing is 18, I've got to figure out just how much this is. Well, this top half, if I look across, is 9 feet. So that means this would be 9 feet. So 9 plus something else has to equal 18. 9 plus 9. So the width of this one is 9. Because if this is 9, then this side is 9. Okay. So now I do 24 times 9. And I get 216 feet squared. So remember, the last step is to add my two totals together. 135 plus 216. And I get 351. Don't forget your units squared. 351 feet squared. Now, we did find the area of the whole thing, but this isn't what we called, like I said from the other day, a multi-step problem. Teresa wants to buy mulch for her whole garden. One bag of mulch covers 12 square feet. So to find out how many bags she needs, we first had to find the area, which we did. The area of the whole garden is 351 feet. Think of it this way, one bag is only going to cover 12 square feet. So if you think back to some of those problems we did the other day, you're going to take your area, in this case, which is 351 square feet, and I need to divide that by 12 because each bag of mulch covers only 12 square feet. So I need a bag for here, and so on. So just divide your 351 by 12 on your calculator and you get 29.25. Okay, now like I told the kids in class the other day, if I go to Lowe's to buy mulch, Okay. If I only buy 29 bags, I'm going to be a little short because this is a little over 29. So 29 bags wouldn't give me enough. And the people at Lowe's are probably not going to tear open a bag of mulch and scoop out 25 hundredths of a bag. Okay. So what you have to do in that case is anything problems like this, you just have to round up, even if you would normally round down. Like I said, you don't want to round down to 29 because that's not going to be enough. So I would round it up and I would buy 30 bags of mulch. Always put a label. 30 bags. Okay. Yes, you'd have some left over, but that's just the way it works. Okay. So that's how you would do a multi-step problem involving a what we call a complex shape. Okay, you would find the area of the entire thing, and then you could, in this case, divide it by the other number in your problem. Okay. All right, guys. Um, I hope this was helpful. I know this was a lot. This may be a lesson that you need to um, go back and maybe rewatch parts if there's a specific shape that you struggle with. If it was the trapezoid um, problem, if you want to review that, if the triangle one, feel free to go back through. If there's any that you missed writing down, please make sure that you do that. Um, check your teacher's Google Classroom instructions to see if they want a copy of your notes. Most likely we will. There will not be an assignment for this today. Your assignment today is to complete the formulas quiz. But tomorrow we're going to review this in class a little more. You will be able to, I would recommend reviewing this video again tomorrow. You will have an assignment on this in Google Classroom tomorrow. Okay. We decided with this being kind of a complex lesson and you already having the quiz today, we would just make your quiz your assignment today. If you get that finished quickly and already have maybe some missing assignments, that might be a good thing to work on today. Um, and like I said, either you will have an assignment on this tomorrow. So look over these notes, review the video again if you need to. As always, guys, feel free to message your teacher if you have any questions. And we've almost made it to the end of the week. I hope you guys have a great rest of your day.